Alright, so now we want to rescale everything to miles and miles per hour. Um, so first off, we have acceleration is our change velocity over time. So change velocity equals our acceleration times time. Well, our change velocity here, we have our final velocity minus our initial velocity. Well, our final velocity is just 0, and minus the initial velocity sine times sine 44, and that all equals, because this our gravitational constant negative 32.2 feet per second. This is negative 79,036.4 miles per hour squared. It's the same thing, just rescaled. So now we could solve, well, this here, our t equals, our time is 2 times this distance, because this right here by itself is just from our initial point to our max height, to the peak of our launch. And so you take that, and since at the peak of the launch there's no more acceleration, then it's just gonna fall right back down. So we multiply it by 2. Okay, so now we have, this is our new t right here. This is 2 times v naught sine 44 over 79036.4. So we take that and we substitute it right back into our our x component here. So now we have v naught cosine 44 times our whole t here. Well, we go ahead and distribute everything, and now we have this 2 times v naught squared cosine 44 sine 44 over 79036.4. Well, we know that our distance, our x distance, was 174.9838 feet, and if we set that equal, we want to solve for our new initial velocity, for our rescaled initial velocity. So we get everything, multiply this to this side, divide that, and take the square root, and we'll have our initial velocity here. So it turns out, after solving this here, the initial velocity is 3,720.6514 miles per hour. Now that we have our v naught, we go right back up here. You plug our v naught into this equation here, and you'll get t equals 2 times our initial velocity times sine 44 over 79036.4, and that comes out to 0.0654 hours. If we transcribe to minutes, that comes out to 3.924 minutes. So the rocket, from takes 3.924 minutes to hit the ground after it is launched.